আমার শুটিং এর মতো করে তো লাভ নেই।
না স্যার অ্যাকচুয়ালি লাইভ প্রথমে যাবেন স্যার?
হ্যাঁ, তাতে কি হয়েছে?
স্যার ঠিক আছে।
ও দেখাটা কোনো ব্যাপার না। Yeah, hello. Good afternoon, everyone. Uh, Welcome everybody to this NPTEL course on Industrial Automation and Control. So I was thinking about having a live interaction session with all students because that really gives a feeling of a nationwide classroom and it's very satisfying. I think it may also be helpful. It will help me to understand the difficulties you are facing, or you may also get to know some things that you that may come to your mind. So you know, being in a course in control, this is real live feedback. Previously we were going, you know, somewhat in open loop. So now we are closing the loop. So I have not prepared anything for this session. I'm not going to teach anything, but I would welcome questions. We already have some questions, and I can answer some selected questions, and we are ready with other questions. So if you have questions, please send them in the chat and we'll pick it up and try to answer some of them to the best of our abilities. If we cannot answer some, we will take them back and we will probably come back to you with more information. Thank you very much. So I'm just asking the staff, is it because I mean I'm not able to see anything. So I'm just speaking blank to a camera.
Yes, sir.
So is there a way that I can see some people can come?
No, sir. Right now, not possible, sir. Only interact with chat.
Oh, but that's not the way it happened last time. Last time I could speak to many places.
Yes, sir. Actually, some places.
So then it is not an interaction that way.
No, sir. Online, just chat session, sir. My interaction
so
with only chat, sir.
No, so then we can chat. Then I mean we don't need the camera.
Sir, all are
seeing your face.
No, they are seeing my face, but you see, I'm not seeing their face. So it is like, you know, speaking to. I mean, I don't know who I'm speaking to. This is not what I expected. Unless you see a face, you don't know who you're talking to. Anyway, so I am looking at the questions. Unfortunately, I'm not able to see you. So I'm looking forward. I'm seeing a blank camera. But nevertheless, let me spend some time. So one question says, I didn't understand the concepts in control systems. Can you suggest some material to study? Well, this is not a question that can be answered because control system is a huge. You can read some standard books. In control system is actually a very big area. So I think there are many excellent textbooks that you can study. For example, there is a textbook by Franklin and Powell, which I like very much. There is a textbook by Goodwin. Who are the authors of that book? Goodwin and, do you know? Do you remember?
Song.
We can look it up. Goodwin control, yeah. Yeah, Goodwin, G.C. Goodwin, Stefan Grabe, and Mario Goodwin, and Mario Salgado. That's an excellent textbook. Probably one of the best control system textbooks that I have seen. Control system designed by G.C. Goodwin, Stefan Grabe, and Mario Salgado. So we are just typing the name. So the name we have just sent it in the chat. It's a fantastic textbook. You can have a look. What are the softwares we need to use for PLC programming according to recent trends? See, you can, every manufacturer of PLCs provide an environment in which you can program. So there are various software environments from manufacturers. Even apart from that, there are other open softwares. I suppose. Possibly we can answer this question better by we can send some information. I am talking to my TAs and compile a list of good PLC programming tools and send. Where can I get some job opportunity details in the automation field? Not really sure.
Another question, a similar question. What is the way or what to get into automation industry being in first year right now?
In first year you cannot get into an automation industry, but there are. So I guess you will have to apply to companies like Siemens, etc. And in fact, there are many. For example, all steel plants require automation people. All chemical processes, refineries require people in automation. Also in manufacturing. So job opportunities are there I think quite a bit, and I mean automation is coming up very much. If you read newspaper, you will see that the manufacturing industry in our country is coming up very well. What is the benefit of this course after my graduation? I guess it's only knowledge. As I wrote in the introduction to the course, one of my students said that one of the benefits of this course is that if you happen to be in a factory, you are likely to understand, recognize equipment and understand what those equipments are used for. That is, in short, a benefit of this course. So unlike other undergraduate courses, particularly which mainly talk about theoretical concepts and they are more conceptual. This course is practical and talks about various equipment and systems. That is one of the benefits of this course. What is the required score of submitting assignment online? I don't think there's any required score. You first submit the answers to the assignments and then you get a score. Currently, I am not very satisfied with your score. I think you have to. The last average score of week 6 assignments were, they were a little simpler. But I am expecting for the level in which the week 6 assignment is there, I would expect at least an average score of 65 to 70. We are getting only 52. So I think there is the scores that I am seeing are not satisfactory to me. Will you please explain inverse system transfer function? You mean inverse response system transfer function? That is also, you can read about inverse response systems. And can I write? Where are the pens?
Yes.
So I think what you are talking about is this is meant for right-handed people. So what you are talking about is inverse response systems. These are systems with what is called right half plane zeros. That means there is a zero, which is like, if you have a zero like S minus 2, if you have a factor in your numerator transfer function as s minus 2 in the transfer function, say gs equal to s minus 2 by s plus 1 into 2s plus 1. So, this kind of systems, this is an system with RSP0. They create problems because the systems have, they are somewhat like time delay systems, and they they introduce extra phase lags, number one, because of this 0 which is in the right half plane. So, any system with 0 is systems with zeros are with right half plane zeros are difficult to control because they introduce phase lag. That is number one. Number two is, another thing is that you cannot, there are many controllers which for example, if you have a system, if you have a planned transfer function which is like s plus 1 by s plus 2 into s plus 3, say s plus 2 into 2s plus 1, then you can easily, and you want to get a, so you can easily, if this is the plant, so you can easily put a controller which can have a transfer function of, let us say, 2s plus 1 on top and s plus 1 at the bottom. So, if you have this and if you have the loop and if you close it, then you see that this 0 and this pole can be cancelled. These will get cancelled, and the transfer function will be, so it will be equivalent to having a first order system. This will be 1 by s plus 2, and this will be, so if you do this, but so this will be your closed loop system. But if you have a non-minimum shift 0, is if the 0 was s, in place of being s plus 1, if it was s minus 1, then you cannot have a pole 0 cancellation like this, because then this transfer function will be unstable and you will get, here the output will be unstable. So, you will get internal stability problem, there will be some signals which will go unbounded. So, these are some of the problems that you have with inverse response systems, but this is again a much more involved concept, and you can read about these in the textbooks that I have mentioned. In our book on industrial automation and control also it has been dealt in some detail. These things are there also with some process control books. So, the inverse response systems are, I think somebody has written, Saish Kalaskar, he has written that he is not able to find more about inverse systems, but I think, can we type inverse response systems in the in Google and see what response we get? I think you will get a lot of response, because it is quite standard in Google. Yeah. So there are I have just typed inverse response systems in Google, and I got many responses, many lecture notes. So you can see them. It's not a very difficult topic to find an answer about. But if you have some specific question, then you can forward it to us and we'll try to answer that. Numerical question and example similar to assignment should be in your lecture, Mr. Mukund Kumar. I understand your concern, but these lectures were recorded long time back, and but I can tell you that the questions and the examples are that you are getting in assignments are completely based on the material that we have covered, and they are not that difficult, but you have to try. You cannot and those questions are actually really designed by us. So you may not find such questions in other books, but since this is an assignment, so you have some time to answer them. So if you carefully look at them, then you can find answers. But yes, they are not in my lectures, because the lectures were recorded long time back. What are the recent trends in, if anybody has any problem about any particular numerical question, then we can answer that. We solve each and every one of them before they are sent to you as assignments. What are the recent trends in process control in industries? This question is too vague to be answered in this span of this thing. Give me some guidance to do some basic prototype projects. No, such questions cannot be answered. Is there any other interesting question?
He wants to know about automation in aerospace industry.
Where is that?
I want to know about automation in aerospace industry. Means any technology.
Automation in aerospace industry. First of all, I don't know exactly what you mean by aerospace industry. I hope you mean, the aerospace. I do not know whether you mean by aerospace industry, if you mean the airlines, then the automation in the aerospace industry, for example, there is a lot of automation in, let us say, luggage handling. So in material handling systems, there is a lot of automation. You can, if you see I don't know whether you have ever gone to a really large airport, but they actually carry out hundreds of, they actually accept and route and send literally millions of pieces of luggage within a very short time. So they use very sophisticated, detecting equipments, various kinds of conveyors. So that's one kind of automation. If you mean the airline service industry. If you mean the airline manufacturing industry, then extremely sophisticated automation is used in airline manufacturing, because you can understand that they are very, very sophisticated equipment, and the equipment in an airline are not really manufactured at one place. So the engines come from some place, the avionics come from some other places, and the body comes, and the final assembly takes place in a factory. So there is obviously a massive amount of manufacturing automation in the aerospace industry.
Another question is that does industrial automation and control include robotics, or is it different?
Of course, it uses robotics. So robots are a part of automation, but robotics is by itself. Robotics is a subject which sort of integrates many other areas. So in this case, we have usually talked about, sensors and actuators, and they are not specifically addressed towards robotics. Although robotics is a part of automation, but we have not dealt with robotics in any detail in this course.
No question till now.
There is a question which says how to make communication between HMI and ladder logic. I don't understand this question. HMI is the man-machine interface. Using an HMI, you can see the execution of ladder logic. As ladder logic gets executed, using HMI you can track, you can change ladder logic using HMI, but that's not online. That's a real-time interface. But even during execution, you can see the execution using HMI. What is the basic formula of PID controller and how to properly tune a handheld PID controller? I don't exactly understand what is the basic formula of PID controller. PID controllers, what is the form of the equation that we have that is explained in the lecture. And some PID controller tuning is actually a very vast area. There are literally hundreds of tuning rules which are applicable to various kinds of processes. So, how to properly tune a handheld PID controller? Handheld PID controller will be tuned just like any other PID controller, and there are various approaches to tune a PID controller. Some of them we have talked about. So, if you are interested, it's a field in itself. But nowadays, I mean, there are auto tuning algorithms, there are manual tuning. So, when you are saying how to properly tune a handheld PID controller, probably you are talking about manual tuning. So, how to properly tune a handheld PID controller will depend on the. You can even do it by trial and error strategies, by working on experimental data, etc. Yeah.
Any innovation via automation that you can think of in avionics industry?
These questions that are coming, they are actually non-specific, and they are not really. I mean, they are just too broad for me to answer. Any innovation via automation that we can think of in the avionics industry. Sitting here, I cannot tell you about innovation. Innovation is something that that one has to work on very seriously for considerable periods of time. Yeah, so then, so let me introduce my TAs. So we have Desham Mitro. Desham, you can show your face. Who is one of the teaching assistants. He is a research student working with me, and there is Dhrupad Bishas, who is also a research student working with me. They are all working in the automotive controls area, working on hybrid electric vehicles. That is their research topic, but they are very kindly assisting me in this course. So Dhrupad is Desham is telling me that whether I can tell you something about Industry 4.0. So being a student of industrial automation, if you want to know at least one very important trend, you can learn about Industry 4.0. Just let's type Industry 4.0. Just write it in the chat. That type Industry 4.0 in Google. So now let us type. So if you type Industry 4.0 in Google, you will find it is Wikipedia says, Wikipedia is a very, I like that source. So although people say that it's not always, not all of it is very verified, that there are various kinds of qualities of material, etc. But that's fine. I find it very useful. So it says that Industry 4.0. Let's read this. So you can also go to Wikipedia and find out. It is if those, I find some people really interested in this current trends of automation and in manufacturing technology. Industry 4.0 is certainly a very major current trend which is sweeping the world. So it is the application of, just like it is the application of communication, AI, information technologies in automation. So it says it includes various concepts like cyber physical systems, Internet of Things, cloud computing, cognitive computing, which is related to AI, and bringing the power of these systems into manufacturing, so that's a very modern trend which is currently being pursued. So you can learn about that. That's something that's certainly worth mentioning. In fact, at some point I was thinking if I'll consider it if I can have some live lectures on Industry 4.0 in this course. I am not sure, but if I can, I will. Yeah. So there are, so they say that there are so far there have been 3 industrial revolutions, and we are right now in the middle of the 4th industrial revolution. So you can read about it. It's very exciting. So
Is there any relation between automation and computational fluid dynamics?
what questions? Is there any relation between automation and computation fluid dynamics? If you want me to answer in one word, I will say no. I wonder whether you have got exposure in computational fluid dynamics. Computational fluid dynamics is a numerical simulation subject. It's a theory of numerically simulating very complex fluid and heat transfer phenomena, not related to automation at all. And a very little connection between them. Yeah? Yeah, so we'll wait here for another 5-10 minutes, and then questions will be great. Then we will close this session. Sir, what is the scope of Industry 4.0 in India? Industry 4.0 is a set of technologies. So it has no scope, not only scope in India, it will have scope worldwide. So it has scope in all manufacturing industries. So it obviously has scope in India in all manufacturing industries. So but these technologies are just being developed. So particularly for students like you who may be interested in looking for research areas, looking for technologies which are getting developed, looking for innovation. I saw somebody asking a question on innovation. Industry 4.0 is a very exciting area. So you may like to know about it. Adesh Tambrakar. Yeah. I will talk about, but there is no question on that. So there is no point talking about it. But I would like to know whether there is any difficulty being felt. Is there any difficulty? Is there any difficulty in assignment? We are not. Are we getting any response in the chat?
Yeah, they are asking some questions regarding that, but they are getting answered. I am answering them accordingly. But not like they are not understanding something. Sometimes they say about
But still, then if there are no major questions, I would like to understand why the average mark is only 52.2. I mean, I am very surprised about that. With 7 days time and our 10 questions, I would expect that the average score will be 100.0. It should be. Why not? So apparently there are some difficulties. I want to understand what they are. I'll tell you one thing. If you want job in automation companies, the first thing you need is a very good academic performance, not only in this subject but in all others. So that's the first thing needed.
how can we learn about Industry 4.0?
How can we learn about Industry 4.0? You are in the age of Google. So you can learn about Industry 4.0 first by reading. Learning is so easy nowadays. Just read. I am surprised by your questions though. Good.
How can you determine stability from Nyquist plot?
How can we determine stability from Nyquist plot? So you have to check gain margin and phase margin. That's one way. You have to check the encirclements of the -1 J0 point. These questions are, I think, very adequately explained in all control system textbooks. If you read it, there are I mean, literally hundreds of examples of how to check stability of a transfer function. Please go and read those books.
What type of controllers used in micro reactors or lab on a chip?
Can't say. These questions, so I mean, this question does not make much sense, because what type of controllers are used in micro reactors? What is the reaction? What is being controlled? Is it temperature which is being controlled, or is it composition which is being controlled, or is it pressure being controlled? It will depend on that. Cannot be answered, this question. Electronics, sir, doubt in encirclement.
Encirclement of the -1 plus J0 point, Nyquist plot.
So actually what we should do is, probably what I am thinking is, শুনুন ইয়ে কোথায় আছে ডাকতে পারবেন শিবশঙ্কর বাবুকে? I think what we should do, this is not the way to do it. I think we should collect questions first and then hold an interaction session.
It's like this, more questions.
Yeah. So I think we should collect questions and then hold an interaction session. So you ask him, what is your doubt? What is the modern day PLC software we need to learn?
That will inform you of the list of softwares.
Not list of software. We will inform you. You can take any standard manufacturer, Allen Bradley, Siemens, and then follow that line. But anyway, we can do a list also. We can study. We didn't study that. What I am thinking is that, you see, these questions that are coming, they are not useful, because they have not. I think. No, that's okay. No, nothing wrong in that. So what I am saying is that it would be much better if we collect questions from students. So we announce that we will have we will have a live session, let us say 15 days from now, and then please give your questions. So we stop 7 days before the live session. We stop taking questions. So there is a 7-day window. When we say that we are going to have a session 15 days later, give us questions. So I will collect 7 days questions, then I will come and answer those questions. That will be better. Right now the questions they are coming, they are not related to the course. They are related very vaguely to the course. Yeah, I am not getting proper. I mean, it is apparent to me that they are not ready. Neither am I ready. If you have to explain something, then you have to come with a preparation. So I think that will be a good idea. Although it was announced, but we will announce like that I will accept questions up to 7 days, then I will close it. I will not accept further questions. But those 7 days questions I will answer. Yeah, so we can have it. So So we can have it just next week. If people send questions in the next, huh?
তখন এইটা আমরা তাহলে এখানে অ্যানাউন্স করে দিই ক্লোজ করে দিই
Correct.
তখন লাইভ সেশন এগুলো করার কোনো
No, that's right. So we can do that.
Just use the closing.
What are the modern? I mean, all the